Alright, now this, just to tell you, this is number 20 in your book on page 146. And what it's asking you is to find the slope of the tangent line, but at a specific point, and then we're going to determine an equation of the tangent line. So we're going to go one step further. Instead of leaving it as a variation, a variable in the slope, we're going to go through and actually plug in numbers. Right, so the first thing we have to do is find the derivative. Okay, so I'm going to work this one horizontally instead of 4 steps, just kind of doing it all in one. Okay, so that would be 3x minus x squared, substituting x plus h in for x. And then I want to subtract my original function. And this time I'm going to start collecting like terms, and some things should cancel. Okay, and since they all have an h, I'm just going to reduce it. You could factor it out. Right, so but what you would have left is a 3, a minus 2x, and a minus h. And then the last thing we'd want to do is take the limit as h approaches 0. And again, that would go away. Okay, now that's the slope of the tangent line at the function 3x minus x squared. So that's at any point. But the book asks us to do at a specific point. Alright, so what do I want? It says I want to find the slope of the tangent line at a given point. Alright, so now I'm going to let x equal to negative 2. So I'd have 3 minus 2 times negative 2. What is that? 3 plus 4 is 7. Alright, that is the slope of the tangent line to this parabola at this point. Now I want to determine an equation of the tangent line. Okay, so now I've got to go back to some really basics. I've got to know how to find an equation of a line. I'm going to use the point slope form because that's what I have. I have a point and I have a slope. That's very convenient. So I have y minus a negative 10 equals the slope times x minus a negative 2. So we have y plus 10, 7x. I think that's going to become positive. If I distribute, that's plus 14. Okay? And that is the equation of the tangent line to the parabola at a specific point. We're going to be doing that a lot, all right? So, this is not a parabola. If you were to graph it, I'm not too sure what it would look like. Okay, but it's definitely not a line, right, since the x is in the denominator. So this is going to be a little bit harder, right? So again, I'm going to kind of just do a couple of examples each way. So I'm going to go back to that 4-step process and say, what if I wanted to do that first? All right, so the second step says, what is f of x? And if I wanted to subtract it, then I would have to change the sign. Oh goodness. Okay. The third step then says to divide by h. Well, I've got some work to do, I think. All right, before I take the limit as h approaches 0, I've got to clean this up. So I'm going to find a common denominator. All right, so I'm going to multiply this fraction times x, and I'm going to multiply this fraction times x plus h. Okay, so let's see. My common denominator is 2 times x plus h. So on the top I'd have negative x plus h, and yes, I'm still dividing by that h. Alright, collecting like terms, I get this. Alright, now, how do you divide by h? That would be the same as multiplying by its reciprocal. Now you can see how convenient that would be. And then the last step I'm going to do, I'm going to take the limit as h approaches 0. I have 1 over 2x times x, which is 1 over 2x squared. Now that is the slope of the tangent line, or in other words, that is the derivative. Okay, but the book wants us to go one step further. All right, we're going to find the equation of the tangent line at this specific point. All right, so I want the slope at a point. So we're going to let x equals to 3, and that's my slope at the point here. Now I want the equation of the line. Now at this point, again, I'm not too sure what the computer asks you to put it in the format of. We could solve for y. Let's do that. So if I distribute my 1/18, let's see, 3 over 18, 3 goes into 18, what? So then if I subtract 1/6 from both sides, okay, that would be the equation of the tangent line to the graph of 1 over 2x at that point. Let's be asked, let's see, the book is going to ask you, how about to find the derivative? And they're going to use this notation, right? It's an f with a little slash, all right? So we're going to find the derivative. All right, so we're going to go through the process. And remember, the derivative is the difference quotient, which is this, as the limit as h approaches 0. So you can see this time, instead of doing the 4 steps, I'm just going to kind of do it all in one. Pick a way that you feel comfortable. Okay, and you're going to reduce. Okay, they all have an h, right? Here, 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 and here, so I can cancel out an h. Okay. And now the last thing I want to do is I want to take the limit as h approaches 0, and I would get 2x plus 2. So that is part A, to find the derivative. Well now, what if I say to find the point on the graph where the tangent line to the curve is horizontal? I want the tangent line to be horizontal. Well, if you recall from that example previously, a horizontal line, the slope is 0. So they're asking you to find the value of x where the derivative equals to 0. Here's the derivative. So I want to say, when is this derivative equal to 0? So I just solve for x, right? And it says to find the point on the graph. Well, this says when x is -1, the slope is 0. But what was that original function? It was x squared plus 2x. Right? Now remember, f of x is the same as y. Alright, so we're going to say y equals what when x is -1? So let's see, that's 1 minus 2, which is -1. So the slope would be 0 at the point when x is -1, y is -1. Don't worry about sketching a graph. I'm not going to ask you to do that on the test. If the computer asks you to do that, you may use a graphing calculator, but don't really worry about that part. Okay, this is number 27 in your book, Part A. It asks you to find the average rate of change. This would be the slope of a secant line, all right? And so the average rate of change really goes back to just the slope of a line. Now remember, that top part is the same as y2 minus y1. All right, so this is the average rate of change. So part A on number 27 says to find that from the interval of x is equal to 2 to x is equal to 3. So I'm going to call this x2 and that x1. All right, so let's see. If I evaluate the function at 3, that's 3 squared plus 3. Remember, I'm looking at that function up here, was at 12. F of 2 is 2 squared plus 2, which is 6. So if I want the average rate of change, I want 12 minus 6 over 3 minus 2. Right? Pretty easy. They also ask you to find it from x equals to 2 to x equals to 2.5. They're just trying to go back to that idea. The secant line, as those two dots get closer and closer and closer, you're eventually going to arrive at the slope of the tangent line. All right, so we're going to do the same thing. Right, so f of 2.5, 8.75, f of 2 is still 6. All right, so we're going to, so we have 8.75 minus 6 over 2.5 minus 2, and we get 5.5. So a little bit different than 6, okay, because those two values of x they're getting closer and closer. All right, so then they say, well, you know what? Let's do it even closer, as x is 2 and x is 2.1. And again, I'm going to be consistent. So let's see, f of 2.1, oops, f of 2 is still 6. So I'm going to use this same formula right down here. So I have, let's see, 6.51 minus 6 over 2.1 minus 2. Get 5.1. Okay, so I started out with 6, then I've got down to 5.5, 5.1. So maybe as that gets closer and closer, maybe we'll get a slope of 5. Let's check it out. All right, so on part B, it asks us to find the instantaneous rate of change. That is the derivative, and they want the instantaneous rate of change at x is equal to 2. All right, so let's see, remember the function was that. So I'm going to take the derivative and then let the limit as h approaches 0, because that h is the distance between the x values. So we went from 2 to 3, from 2 to 2.5, 2 to 2.1, so we're getting closer and closer. Now we're going to be exactly at 2, so we'll have a tangent line. All right, so let's see. We would have, okay, we can reduce our h's because they all have an h. Don't leave out that 1 at the end. H goes into h one time. And then we're going to take the limit as h approaches 0. So that's 0. And I get 2x plus 1. All right, and now we need to find the instantaneous rate when x is 2. So we're going to plug in 2 right there. 2 times 2 plus 1. Lo and behold, it's 5. All right, so when they ask you to compare the results, hopefully you can see that we went from an average rate of change, the slope of the line, rise over run, like we started out with on the graph, and then as we let x get closer and closer together, we get an instantaneous rate of change, and that is the derivative. That's the slope of the tangent line.